Before we proceed, let us discuss a little bit on the importance of the simple harmonic motion. As we have discussed before, that if we draw the diagram of the potential energy as a function of the distance of the system in nature, we always found the potential energy like this. The potential energy has the shape of the wheel. As the shape of the wheel. That is, you have the minimum value of the potential energy here, and we can say that this is the equilibrium configuration of the system. It means that the system will try to arrange its configuration to be at this point that the potential energy has the minimum value. Okay, this is like when you drop an object, it will try to go to the floor because at that point the object moves to the point that the potential energy is minimum. It will seek the way to go to the minimum value of the potential energy, and we call this the equilibrium configuration of the system. Mathematically, we can show that any curve of this shape that you have the maximum value, and this is the value of the curve around like this. We can use the mathematical technique called the Taylor series expansion, which I will not give you the detail here, but if you study the higher mathematics course, you will certainly have to study this Taylor series expansion. But the point is that using the Taylor series expansion, we can show that close to the equilibrium configuration, it means that around this area, the the orange curve here can be approximate, as the dash curve. Only allow the equilibrium configuration. You can see that the dash curve is almost identical to the orange curve, and this dash curve is the parabola, which is the characteristic of the simple harmonic motion. Okay, if we look back to the previous slide, you can see that this is the curve. This is the curve of the potential energy, and it is the parabola. You can see also when you look at the expression for the potential energy, you can see that it is a quadratic function, so the curve is a parabola. And from the technique, the Taylor series expansion, it tells us that allow the equilibrium configuration. The orange curve can be approximated as a parabola allow the equilibrium configuration. So we can use the simple harmonic motion to explain the change of the configuration of the system near the equilibrium configuration. So that is one of the important of the simple harmonic motion. We can use the simple harmonic motion to explain the behavior of the system close to the equilibrium configuration, like in this figure. The atoms in the lattice has the interaction with the nearby atom, but close to the equilibrium configuration, we can approximate the interaction between each atom using the spring model, the simple harmonic motion model. That is, the interaction can be approximated as the interaction from the spring. So you can approximate the behavior of this system using the simple harmonic motion model.